My name is Klaus Dürrschmid. I'm working at the University of Natural Resources and Life Sciences, and since 20 years I'm dealing with sensory science. At the beginning we focused on sensory perceptions, liking, wanting, things like that, how to describe food products in sensory dimensions objectively. But very soon things developed in a completely different and more complex direction. We saw that liking is a very poor predictor of market success, for example, and so it became obvious that there are several other cognitive mechanisms that we do not measure but play an important role in controlling our food-related behavior. And therefore we focused more on alternatives to liking tests, sensory perception tests, for example observational techniques to measure emotions or to measure the gazing behavior, things like that. And we hope that this will give a more complete picture of the behavior control of consumers.
Mm-hmm. And you have used this kind of technique and also the idea behind it in your last publication. It was a publication that was co-funded by ESN called Are Implicit Emotion Measurements Evoked by Food Unrelated to Liking? Could you please tell me a little bit about this paper?
The main objective of this work was to screen several implicit techniques of emotion measurement to see whether they could contribute to an explanation of market success of several products. And we therefore used several implicit techniques like emotive projection testing, autobiographical congruency testing. And we also did several other methods like face reading to measure spontaneous emotional reactions in the face. And we used eye tracking to characterize especially the packaging of the products. And we also did the conventional measurements like expected liking or tasted liking, things like that. And then we had a look at the market success of the products and tried to correlate the market success with the various measurements. And we also intended to see whether the liking and the measured emotions do correlate, or whether there are differences or not.
And so what did you find out?
We saw first that the face reading technology is not easy to use, especially when it comes to food that has to be processed, because so many muscles get active in the face that you can hardly measure slight small emotion changes in the face. So we saw face reading is not able to measure any emotional reaction caused by the food products. Then we saw that the method of emotive projection is the best method to differentiate between the products.
Maybe you can give a short description of the method?
This method is very simple and very cheap and it doesn't take very long time, so it's a perfect method if you ask me. You simply have to be confronted with a stimulus. In our case it was yogurt and different kinds of yogurt. And after having eaten the product, you just have to look at several pictures of persons. And these persons are very indifferent in terms of emotional expression. So you can't really say, is this a happy woman or is she, I don't know, disgusted? It's not very clear. If you just had a positive experience, you tend to project your positive emotion in the interpretation of these pictures. So if you had a positive emotional reaction, you will interpret these pictures as happy and cheerful and so on.
So instead of filling out a scale from 0 to 9 and say, that makes me feel happy, 8,
Yes.
you would look at the picture and without actually knowing it, that it's about your emotion, you say, oh, this person really looks very happy. Huh?
Yes, that's part of the implicitness of this test method. You do not focus on the food you have just eaten. You even do not know that your emotional reaction is measured now. You are focusing on emotions of other people. And you do not know that actually you are telling the others that you just gave a measure of your emotional reaction. So it's a very clever testing method, and it was the best method we had in our experiments.
And what did it show compared to classical liking?
First, we had 3 pairs of food products, and in 2 of these 3 we had significant differences in emotional reactions measured with this emotive projection test. And in both significant results we saw that there was one product which gave more positive emotional reactions. And these were the products which had a higher market success.
And they also received a better liking?
Yes, a bit in some cases, but the correlation between the emotional reactions and the liking was very vague and not significant in all cases. So we can say that this emotive projection test is delivering more information, different information than the simple liking test.
And could you see that then maybe industry or research institutes are interested in using that kind of methods to predict market success?
Yes, of course they are highly interested in using this method. Since it is a very cheap and quick method, you don't have to invest money. It would be perfect. To my opinion, this method will be a part of product development in the next 10 years or so.
Area you're also very active in using methods to measure food choice behavior, for example, eye tracking, face reading. What made you go into that direction?
Well, when we started, we focused on sensory perceptions. This means that we ask people, how do you like this food, and please quantify the sweetness on this line scale or so. It's clear that all our test persons did explicit tests. So they were thinking about the question, what did I feel, what did I perceive, and how could I quantify it on the scale. So there is a lot of thinking about the perception. And this thinking might bias the result tremendously. And we know from the psychologists that our behavior is not controlled only by conscious mechanisms, but by many unconscious mechanisms which we are not aware of. And therefore we decided to go not away from explicit measurement, but to add implicit measurement methods in which the measurement outcomes result from automatic processes. The test person cannot control the outcome, even is not aware what is measured now, and if the test person would know what will be measured, she or he could not control it, he could not bias it by will. So that would be the goal of the implicit measurement. And we are using techniques which are under discussion in the scientific world. One is eye tracking, by which we are measuring the gazing behavior of consumers when they look at food products or packagings or web pages, if you want. You can see what is the first area of interest they're gazing at, which is the area they're gazing the longest time, and things like that. How often do they look at a certain area?
How is it done technically? Is that all included in the monitor, or do you need devices that are put on the glasses or on the eyes?
There are several different techniques, and the technique we are using is implemented in a monitor. The eye tracker is on the bottom of the monitor, and if you sit in front of the monitor, you would say old-fashioned monitor, nothing else.
So you don't even notice that your gazing is tracked.
You're looking at the picture right at the monitor, nothing else. And that's very interesting, not only for the development of packagings and information material, but also to investigate choice behavior. We are dealing with eye tracking in two directions. The one is what is influencing gazing behavior. Of course, it will be the light conditions, the position of the products on the screen, the size of the objects, or the contrast, the colors, things like that, of course. But what we are also interested in, that's the second dimension, is what do our measurements mean? Can we predict anything from the gazing behavior? And what we soon saw is that there is a correlation between gazing behavior, certain gazing behavior attributes, and choice rate. We saw that people who are very often looking at an object tend to go for this object. So they will choose it. And it's not the time to first fixation or things like that. It's simply the number of gaze counts and the total gazing time. These two correlate positively with the choice rate. And in the first experiments, we got correlations about 50%, so we could predict the choice from the gazing data with 50% accuracy. And now with several statistical models, we can predict it to more than 90%.
And I try to figure out, so what is the advantage of this method? You have to put more work in than just asking people, fill out this internet questionnaire, and that's what probably now is done most of the time by market research.
Maybe it's not an outcome which can be used in everyday life of companies. For us, it seemed interesting to see that the decision process is reflected in the gazing process. So during gazing, obviously people are already deciding, and this decision process is not, you cannot make a difference between these two. So maybe in the future you don't even have to ask people which one do you want to have. You simply have to observe their gazing behavior.
Also, this is maybe a method that can be integrated in virtual reality testing, where you just check via the glasses where people are looking at in a virtual reality.
And I mean, consumers are able to lie, not to say the truth. And if you have a look at their gazing behavior, it's not that easy to lie, especially when you're doing implicit tests.
And do you plan right now some studies with gazing behavior?
Well, what we were doing in the first tests were tests with food products like apples or bananas, fruits, vegetables, bread and things like that. And now we are testing branded products. And what we see now is that the decision process is much quicker for the branded products than for the non-branded products. But the principle is the same. Gazing counts and gazing time is a good measure for the choosing behavior.
Is there anything one can do to easily enhance gazing time?
That's the first dimension we want to investigate. What is influencing the gazing behavior? And of course, colors, shapes of products, color contrasts, and also the order in which you show the products are influencing factors.
Yeah, you're not only using eye tracking, you're also using other methods, for example, face reading. What does that mean?
Yes, the face reader is our second observational technique. It's a method to measure emotional reactions in the face, facial reactions, which can be spontaneous, and we are using a system based on FACS, which is the facial action coding system, and this system encodes the muscle reaction patterns of the human face. If you can measure the activation of certain muscles in the face, you know whether this face is looking disgusted, happy, or sad, whatever. And the problem with this method is that many people do not show many facial emotional reactions, especially adults.
They show their poker face.
Yes, they have learned to control emotions, especially when they are amongst other human beings. And this is an interesting result of our research in this respect. We saw that people who are alone in a test booth, for example, never show positive facial reactions when they smell on a certain odor or a certain food.
Even when they like the food or the odor, they don't smile just by themselves?
No. When they are alone, they know that they are not observed. They simply do not show positive reactions. At least with our food products, we were using orange juices and different other fruit juices. But all of a sudden, if you tell them that they are observed now and that we are measuring the facial reactions, then all of a sudden you have to smile when the product is good and they like it. So this shows that these emotional reactions are part of the communication system of humans, and you have to be very careful what you tell the test persons, what they are doing now and what is measured.
What were some of the outcomes that you gained with face reading?
Yes, another thing what we did with the face reader is to see whether there are correlations of the emotional reactions in the face with autonomous nervous reactions of the autonomous nervous system. We were measuring the skin conductance level, the heart rate, things like that, and saw that there is a correlation between disgust and skin conductance level. We didn't find any other correlations, but if people do not like a food, they begin to sweat, obviously. That's the reaction of the autonomous nervous system.
Are there any other methods that you have tried in terms of observational methods?
We have the eye tracking, face reader, and reactions of the autonomous nervous system, some of them. There would be many observational techniques we would like to use, for example, brain imaging or things like that. But we obviously need here collaborations with different disciplines.
And what is your next project, or the project you're working on right now?
At the moment we are doing very applied research in context with eye tracking and face reading. Companies are involved, and we try to implement these methods for the daily product development, and see how it can add to the normal methods they are using. And another project we are dealing with is a little bit off this topic, but it's highly interesting in a way. It deals with odor and age associations. This work bases on the idea of conceptualization, which says that it's not so important what we perceive, it's important what these perceptions get in terms of meaning. And so we tried to find out whether normal, naive consumers are able to associate age stages to certain odors. And this was the idea of a colleague of mine, and I didn't think that we would have any reasonable results. But we could show that people are highly significant able to assign odors to age stages, meaning childhood, adolescents, adults, and elderly people.
For example, what kind of smells are associated with the different age classes?
We had only around 10 smells, and typical smells of childhood are confectionery and vanilla, for example, and typical smells of seniors, the elderly people, nut smells and spicy brown. And this is strange in a way, but we had 300 test persons, so it was not a small study anymore. Various groups, 4 groups, kids, adolescents, adults, and the seniors. And each group is assigning the meaning of the smell in the same way. So the kids say nuts smell like the elderly people, and the elderly people say nuts smell like the elderly people. That's the same for all age groups. And well, we don't have any explanation for that fact, but it simply appeared to be. So maybe there are associations with certain food products which are consumed more by children, like confectionery, vanilla, ice cream, or something like that. I don't know. Maybe it's correlates to the seasons. I mean, the nut.
At the end of the year, there's a nut. So it's at the end of the life.
The association, right? It's attributed to elderly people. We don't have any idea. But what we also saw in this study was that people do not like the smell of the elderly people. I mean, in the sense of the odors which are associated with elderly people. So the confectionery and vanilla aromas are very highly liked, and the other aromas less liked.
Oh, fascinating. Then thank you very much for the interview, and I'm looking forward to a nice workshop and meeting here in Vienna.
Thank you, Fabienne.